Yeah, okay. So when you start writing your programs at the beginning of the semester, what is your what is your usual debugging strategy? How did you debug your programs? Okay, printf. So the most popular debugging techniques. If you think of debugging techniques, the most annotations not visible. Okay, now it will be done. So yeah, so first is of course printf. Not only as a beginning programmer, at any level, you know, printfs are a very good way of happening to see what is happening in your program. And the second approach, of course, is you use GDB. So these are two popular techniques. See, debugging is always manual, but GDB makes your life a bit more easier. So now let's take a look at the insertion sort code that we have written some time back. Okay, and see perhaps how we may So this is the insertion sort code that we have seen before. And yeah, so let's say while writing code for your insert node function, in order to understand what's going on, you may have something like printf. I'm in insert node. Base -1. And then there are 4 cases we thought of /n. Inductive case. Okay. So now I printf not printer. Okay. Thank you. Okay. Okay. So now GCC insertion sort.c .a.out keys.text. So as the program ran, so different statements, initially we entered the base -1 case because the linked list is empty. So when you are inserting the first node, naturally we enter base -1 case. And when do we hit the inductive case +1? When we are inserting it at the end. Yes. Good. And inductive case is the place when we are inserting it in the middle of the linked list. So after you debugged your program, so you want to submit it. When you want to submit it, what do we do? What do we do after when you want to submit your code on OJ? When OJ, even if you put an extra /n also, OJ will say, you are out of the game. So when such is the case, so you have to, we comment out all these debug statements. But commenting them out, so I have printf statements in 4 places, and I have to go and manually insert these comments, which is a painful thing. And if I am working on really big software with with thousands of lines of code, many hundreds of debug statements, then manually going and changing them, it's not an option. So what do we do? So we use the C preprocessor macros. So we say if def debug, then do this. Debug is a macro. No, you do this only once. You want to change comment, uncomment, you do it all the time now. But this one you do it, you will see the power of this in a while. Okay. So now if you want to, so GCC insertion sort.c, line 70. Oh, okay. So GCC insertion sort.c .a.out keys.text. So it all worked out fine. So nothing got printed because the macro debug is not defined. So all these printf statements, they are gone. And remember, in this program, we are not doing anything. We are just printing this. Or perhaps to make this more interesting, at least we can print what is their print list. See, this is what it is. So now that's the question. So, but if you want debug to be enabled, there are 2 ways of doing it. One is at a compilation time, you can use -D debug and insertion sort. And then when you do a.out, then keys.text, then all the debug statements are printed. In a single, so this is one way. At the command line, you can give this command gcc -D debug. The other way is you go to the program and you just say #define debug. This will also work. See? And if you want to, you can just comment it out if you don't want to do it. So you can run this keys.text. So, but going to the source program and modifying it every time is a pain. So usually what we want to do is we want to work on it using this approach. Whenever you want to debug your program, you use the debug option, that you use the define debug macro option, and you compile, and all your program will be, it will run. Okay. So please dot text. No, debug you are defining by your own. It's not there anywhere. Debug is not there anywhere. It is your user defined macro. It can be anything. It can be, instead of debug macro, it can be anything. So are you all with me on this? So when you work, when you debug your program, you use this debug option, you run, and when you submit it on OJ, this is not anywhere defined. So all your debug statements will not even be printed at all. When your program is compiled on OJ, this option will not be used. So because of that, all the debug statements that you have in your program, you don't need to do anything about them. Think of it as something, it's just a macro is the same macro. We are defining debug as a null. Okay, nothing. Okay, there is no definition. Yeah, that's true. You can define any macro at the compilation time itself. So, but now, so instead of this, okay, there is you can have different approaches also. Instead of if-def debug, you can have a different approach. If we can have different levels of debugging. If def debug greater than 1, or if debug is greater than or equal to 1, you print this. So now what happens is, so if you define debug is equal to 0 and you compile this, then what happens? Are you with me here? Because we defined debug to be equal to 0, and these statements are invoked when the debug level is greater than or equal to 1. So they are not invoked when we define it equal to 0. But when we define it be equal to 1, what will happen? Now all the debug statements are printed. Are you all with me here? And then if you want to have a deeper level of debugging, you can have something like hash if def debug greater than or equal to 2, then we do this end if. What do we do? Printf state of the list before %d is inserted. Anything, any macro you can define just by -d. D stands for define. State of the list before, and then what do we have? We have print list. Are you seeing what we are doing in this code now? Are you all with me here? State of the list after %d is inserted, and then print list. So now we are doing a deeper level of debugging. So if you want to do a deeper level of debugging, so you use 2, define debug is equal to 2, and then you run it. .a.out keys.text more. Now you can see, I would like you to pay attention. Sorry, /n. see, I wanted to pay attention here. So how we are able to do state of the list before -2 is inserted. This is when the list is empty. This is an empty. And we are inserting the node because it's a base -1 case, because head is pointing to null. And after we insert, this is the state of the list. -2 got inserted. Are you with me here? So why it is a base -1 case, why the list is empty, base -1 case is invoked, and after -2 is inserted, this is the list that we have. Now, we want to insert 1, 2, 2, 3, and so 1, 2, 2, 3, we are adding it at the end. So it is a, what is this case? This is a inductive case +1. And after you insert, you get -2, 1, 2, 2, 3. This is what we have. And then now when we come here, so you know -2, 1, 2, 2, 3, -2, 1, 2, 2, 3, and 7 is inserted between -2 and 1, 2, 2, 3. So what happens? So 2 points to 7 and 7 points to 1, 2, 2, 3, and this is what happens. This is the state of the list after 7 got inserted. So this is how we are able to completely trace how insertion is happening when we are trying to debug the program at a debug level 2. Are you with me? Yes, no? Do you see how you can see that you can, when there is a bug in your program, when you give a detailed print like this on the screen, then no, it will all be. So why did we do more? Because otherwise the screen will just go. More will show what we can see on the screen, and it will stop there. So that's what. Okay. So it's the same debug. It's the same in multi-files also. It's not going to change. So now if we just compile this GCC, and then it all looks good, you know. So all done. So you submit your code to OJ and nothing happens. OJ sees the program output. That's it. You're all with me here, completely happy with how we are using the debug macro. And there is a question on how do we use. So now that is interesting thing. We just make debug here in the make file, then that's it. Everything is compiled using this thing, and that's it, done. Now you understand the power of make files, why we are using C flag, CC. Wherever $C flags is there, it gets replaced with -D debug. Okay. Awesome. All right then. So this is about debug, and you know, like when we in the insert node, what is the assumption that we will have after line 39? When we do an allocate node, did we make any assumption about n, the variable n, the memory that is allocated to variable n, or the node to which? Yeah, there is this assumption that n next is equal to null. Okay, this is what we have here. So the invariant, this is what, because someone may look at this code, sometime someone else could be working on this code, they may look at line number 23 and they may think that it may not be necessary, and they may comment on this code or remove this code. But if this is not there, then what happens is the program will break. The insert or everything that we do, in a linked list will break. So perhaps we may want to keep this assert statement here. Okay. Are you all with me? This is the invariant that we want to check. This is the invariant that we want to check. So now if we go and compile this code, now GCC, in order to use, whenever you use assert, no, you use hash include assert.h. Okay, so GCC insertion.c.a.out. What will happen now to this code? What will assert to do? So if you see assert, if this condition is false, the assert generates an error message and aborts the program. If this condition is false, the condition expression that we are giving to it, if it is false, assert will break, will abort the program and generates the error message. Interestingly enough, what happened is when we don't make n next equal to null, it's not guaranteed. It's not guaranteed. Okay, it's not at all guaranteed, but for some reason it is being set to null. I don't know why it is the case. Okay, I expected something bad would happen here, but it is not. No, the assertion would fail here, but it's not happening. Okay, why it should be set to equal to null, I don't know. Okay, it's not guaranteed at all. Or maybe let's look at the man page of malloc. Man malloc. See, the memory is not initialized. The malloc function allocates size bytes, returns a pointer to allocated memory. The memory is not initialized. Since the memory is not initialized to anything, then there is no reason why this should be equal to null. But anyway, it is happening. But let's say, had it been the case that this is a random value, something like 1, 2, 3, 4, okay, then if you compile this program, then let's see what happens. And you see, then there is a assertion failure. It says on line number 43, of the file insertion sort.c, there is a violation that is there, and that because of the assertion violation, the program got aborted. So usually when you write your the very good practice, there is no sphy segmentation fault. The program is aborted. Okay. Usually when we write your programs, especially when you are writing very difficult logic, you may want to assume that before you write a chunk of code, what are the preconditions for this code and what are the post conditions for the code you can have. And these pre and post conditions, you can encode them using the assert statement. And this is an excellent programming practice. When you are working on a difficult code and it's not, things are not, you are not able to figure out what are the problems that are occurring, logical problems. Even before you see the problem, you want to go about it systematically. Then you will have to think, when I arrive at this point in the program, these are the conditions that needs to be satisfied. And once I am done, once I run through this code, and these are the conditions, post conditions that needs to be satisfied. So you use an assert statement to put this pre and to encode your pre and post conditions. This is an excellent way to easily to go about writing your code in a systematic fashion. And if you don't want assertions to be enabled, you have to define this Debug, which is there already, and so you don't need to do anything. Then assertions are not then assertions are not enabled. Why did we get a segmentation for core dump? Because accessing memory location 1, 2, 3, 4, exactly. Okay. So to give an example of a post condition, let's see. Are you all with me on this example? Why, where, and why we want to use asserts? So here you have seen an example of a precondition, that is before we start with the insertion code, before we start with the insert node code, the node that we have allocated, the next field in it should be equal to null. That is the precondition that we would like to have. Now take a look at the sortnames.c program. In the sortnames.c program, let's say after we read, okay, after we read, what is the post condition here? What is the post condition? The post condition assert here is number of names is less than or equal to max number of names, because that is how we have defined our the number of names cannot be greater than the max number of names. So let's say we'll have it as 10, and this is a sort names function. Let's compile a sort names function, gcc sortnames.c. I have to include assert hash include assert.h .a.out less than names.text core dumped. Why is it core dumped? Maybe names, no, not really. Let's see. gcc -g names.c gdb a.out run less than names.text bt. Okay. Yup. That's the problem. The number of names are 8. That's not the thing. Something happened in the bubble sorter. What happened in the bubble sort? Number of names. Where? What did we use? Akshat is telling something. We worked on this code, no? Before. BT bubble sort. Line 47. String compare. Okay. I got an interesting undefined. How do we compile it, Ajit? Minus F sanitize equal to address. Missing. Ajit, can you give the whole command line for me? Okay. Copy. Thank you, Ajit. But we debugged this program, right? So before, should I just do GDB or? Okay, dynamic stack buffer overflow. In read names. Okay. I see. How many names are there? 8 names. Maximum number of. But we debugged this program, right? So why are we getting this thing now? Names, number of names. Is this because of this? If this doesn't work, I have an alternate way of solving this problem, at least for the time being. Oh, okay. I see. Yeah. So there is this problem. This is not supposed to take it from, okay. Enter the number of names. This is there. And then read names. Okay. I see. Got it. We changed the code after that. Because of that, I think this should now work. Awesome. 57 bytes leaked in 8 locations. Nice, cool. Thank you, Ajit. Nice. So I learned something new. This F sanitize option is doing some cool stuff. I never used it. Okay, good, no problem. So yeah, let's go back here. Let me compile the program without Ajit Babu's awesome parameters. It is running. So now let's say so honor Ajit by entering Ajit in his name in the list. And Vansh. Ajit Babu. Okay, Ajit Babu. Now we need Galaxy. Okay, now. So now let's see what happens. Yeah, number of names. Why this is not stored? Where names.txt. We commented what? Max number of names is 10 now. Oh, we commented the assertion. Yes, yes, yes. See, now the assertion failed. Why we didn't get a segmentation fault? It's a very interesting thing. Yeah. In which one? Previous one? Now also, you know, we read the names and then we got the assertion error. There's actually, we are using more memory than we are supposed to use. So here we are using more memory than we are supposed to use. But then what happens is it is still going through, this code is still going through, but this error, it will get reflected somewhere in some other later on down the lane. The mistake that we did, because we allocated memory only for an array of 10 character pointers, but we are reading more. But right now we are not hitting any problem in the code from 14 to 18, but we will get caught at some other place and we will not be able to correlate why the problem has occurred there. So it takes a lot of time for us to figure out, you know, hey, we have allocated the maximum number of names that we can handle is 10, but we are reading more number of names. So, you know, so that's the causing the problem. So all these things, it takes time. Okay, especially when we work on really big code. This is very small code. So it is easy to isolate the problem and figure out what's going on. But when it is big code, then you are in big trouble. Okay, because the problem occurs somewhere. Like for example, when you have food poisoning, you know, then you eat food at n number of places. You know, where what is the source? It takes time to figure out what's the source. So similarly, like this, the effect will be somewhere, but the input is somewhere and the output problem is somewhere else. So in order to kind of establish a causal relationship, it takes it's going to be hard work. Line 18, it doesn't require a semicolon, it just means an empty statement. This is an empty statement, equivalent to an empty statement. It's a mistake, we don't need it, but it means there's an empty statement. Are you all with me on this one? How we can use assert? Yes, no? Can you think of, can you guys tell me one place where you would have used assert and solved some debugging problem you faced? And taking input from the user. Okay, think about it. Runtime errors, perhaps. Overflow, yeah. See, there are places where you want to give the user, hey, you know what, this is an error, and you come out. And there are places where you want to use, I want you to understand this. Actually, the example I gave is also not a nice, great example. The places where the program is getting into trouble because of a incorrect input from the user, you don't want to handle it using assertions. You want to give an error to the user, error message to the user. Are you with me? The places where instead of this, we could have done something like if number of names is greater than max number of names, you know, you could perhaps write something like printf error, some user error message, and then you can say exit 0, and then this code you can have you can have this code something like this here. So you can do, this is the right way to handle this, okay, or maximum name length. But we want to use assert in your programming logic, which is not visible to the user. Like for example, this is the place where we wanted to, the user doesn't know anything about n next equal to null. He doesn't know anything about it. Okay, this is a problem on your end. How does the user know about anything about whether you are using a linked list or an array or a tree or whatever? So you want to use assert is on the intermediate state of your program, which is not correlated with the user input. Okay. Are you all with me on this? Where to use assert versus where to use an approach such as this? I hope you understand what I'm trying to say here. That here, this is not the right usage of assert. I gave not a great example. This is a user thing, and you have to tell the user, I cannot handle this many number of names. So do something. All right, so this is about assertions. In the last 10 minutes, I would like to talk about a mem leak. What are memory leaks and how can we determine memory leaks? NTA have to learn about assert while releasing. What is NTA? Oh, okay. Pardon me, ignorance. Okay. So take a look at this code. So what's wrong with this code? A chunk of memory that got allocated, we are losing a handle of it, and we will not be able to use the memory that is allocated on line number 5. We will not be able to use it after line number 7 because the only handle that we have for that memory is lost. It is like this. You deposited your money in your locker and you lost the key. And once you lose the key, then you will never be able to access the money or whatever that you have in the locker. Right? So losing the handle to this address that we got allocated, it never you will never be able to use it. Yes or no? Are you with me on this example? And the way we can do it is check whether there is a memory leak in the program or not is by using a program called as Valgrind. So now when we run the Valgrind says in use total, where is this? Definitely lost 40 bytes in one block. So why 40 bytes are lost? Block is some chunk of memory because we allocated 40 bytes in as one block of memory, and we lost it. And if you run this one using minus leak check is equal to full, then you can see it says that 40 bytes in one block are lost. And where is it lost? It is allocated on line number 5. Okay, on line number 5, the memory that is allocated on line number 5. Okay, this is on line number 5. It is lost. Do you see how Valgrind detected the memory leak here? So in order for you, let's take one more example. Are you all with me on this example? That we lost handle to the memory or the treasure that we got, and it's a leak. It's never is available for us. So now let's look at the code, memory2.c. So here is the memory allocated on line number 9, is it leaking? Is the memory allocated on line number 9, is it leaking? How about the memory allocated on line number 12? It's not, we are releasing it. And the memory allocated on line number 16? The program is ending. So by the time the program is coming to an end, that memory is still allocated. Okay, that memory is. So now let's compile this program, gcc -g memory2.c Valgrind. Let me use, So now when we use this, it says heap summary in use at exit 35 bytes. Yes or no? By the time we come to the end, these 16 bytes of memory and these 19 bytes of lost memory, they are still there on the heap. Right? 35 bytes of memory in 2 blocks in use at exit. It makes sense, right? This. And then these 16 bytes of memory, this is 16 bytes in one block are definitely lost. In the sense they are lost 16. Yeah, because we are not freeing it. So because of that, Valgrind thinks, you are not releasing the 16 bytes, so it is lost. Similarly, 19 bytes are lost on line number 9. 19 bytes are lost on line number 9. So overall 35 bytes are lost. And we are making 3 allocs and 1 freeze. Even if you have a handle on it, oh, that's true, but Valgrind just thinks, hey, you allocated this memory, by the time you are there, it's don't worry about it. I also don't know, you have to check. But essentially what I want you to understand, if you understand one example, I'm just happy. Line number 9, is there a memory leak or not? Memory allocated on line number 9? Yes or no? Why is there a loss? Because the handle, the memory that is allocated to it, the handle is lost and we will never be able to access it. Now, in the programs that we have seen something like this, right? A structure with the char names and then int age. Okay. So when we allocate memory for this structure, there are 2 fields. One is names and other is age. This is the memory that comes from the heap. And then there is a memory that is allocated for names also. So now my question for you is, when we free the name, when we free the memory associated with this structure, is there any memory leak? When we free the name associated with this structure, is there any memory leak? No, yes, no, there will be memory leak, right? But because if there is 100 bytes, you free this memory, the structure is in the heap, okay? So if you free this, if you free this green structure, then the handle to the 100 bytes of name is gone. Yes or no? So you have to free the memory that is allocated to the names, this array, and then free this one. So the freeing process is a two-step process. You free this one and then you free this one. Okay, free, this is step one, free the memory that is allocated to this name, and then you free it, this structure. But on the contrary, if your declaration is instead of this, if it is just char names 100, do you require 2 levels of memory deallocation, freeing memory? We don't need it. If you just free the structure, 104 bytes are automatically released. Because these 100 bytes are now part of this, they reside here. You're all with me? Yes, no? Do you see the difference between the two cases? If it is char star star, I also don't know what happens at now. I'm just kidding, but just understand this particular example, okay? You just have to extend the same logic there also. Line 16, don't worry, okay? Because what is happening is before line 6, after line 16, we are coming to an exit. So, but let's say if I say P is equal to null, then definitely line 16 is a leak. Because we are losing the handle. Okay, Akshat? But in the absence of this, it's just an interpretation, whether you want to think of it as a memory leak or not. Because once the program exits, everything, all the memory associated with the program will be released. No, everything associated with the program will be released. The process dies. Okay. Okay, that's all I have. Don't worry about it. Just see whether the way I am seeing it, Valgrind is thinking of line 16 as a memory leak. It looks like that. Because it's not freed. From Valgrind's perspective, it is not freed. Line 16 is not freed. So because of that, it thinks it's a leak, perhaps. It's never reclaimed. The memory allocated on line 16 is never reclaimed. Because of that, Valgrind thinks it's a... Okay then, so this is all I have for you today. So you understood what is a memory leak? Yes, no? 60. Bye C programming, Galaxy. Oh, Galaxy. We have exam, final exam. Oh, sorry, Nikita. See.